Okay. So, share my screen. You guys see the screen? Is it another screen?
Yeah.
Okay. It says introduction because I don't know why it's opening up on my other one. I hate how Zoom works on this. Okay, I hope you can see this. So what is web scraping? So what we're doing today is web scraping. So what is web scraping? We're going to be taking data from websites. So like your favorite websites like Google or whatever, the way they can aggregate data, the way they like when you search up like hello on Google, like the way they have like 258,000 results like that quickly. Well, that quickly is just the computational power of Google. But the way they have all this data, all this data is they use web scrapers, and in aggregate they use web crawlers, which kind of they go hand in hand. Today we're gonna try to build our own scrapers. So scrapers, all they do is take data from websites. So like this website, it'll take the metadata of this website and put it on Google. And so that's like web scraping. You're going to see once we get into the examples here. What is web crawling? Web crawling is pretty much like it says it over here, an internet bot that systemically browses the web for the purpose of data indexing. Like I said, the Google search engine. So how are we going to do this? We're going to use Python 3. Specifically, I'm going to use Python 3.8.3. That's like my favorite version because I have it on everything. We're going to install that together later on, but I'm just going to tell you what we're using. We're going to use BS4 or Beautiful Soup. This library pretty much allows us to browse kind of, or not browse, but parse HTML data. So you can see right here, like it'll take HTML data, it'll make it easy to enumerate data, if you will, and parse it through like our code and whatever. So this is a very useful kind of library that we're going to use, and it's written in Python. We're also going to be using HTTP web requests. So pretty much what a web request, if any of you aren't familiar, if I were to like curl, which is just like, actually, here's a better example. If I were to just go to google.com, you can see that, well, this is just a GET request. If you see like me going to Google, if I were to just google.com right here, this is a GET request. So HTTP, google.com, GET request 200, and that's good. So all that's doing is it's just kind of getting data from google.com. So if I were to just get http://google.com, pretty sure this is S. What it does is, I mean, you're not supposed to do it like this, but pretty much what you get is the HTML data of the Google website. So, and if you're familiar with HTML, it's just like how how websites are structured and how your browser gets to see it. So we're going to be parsing this data from whatever website we're going to go through. So that's what a web request is, and you're going to see that once we get into code. So let's get our workspace set up. So what you need is Python. I have this version right here, Python 3.8.3. I can actually, if none of you know how to download it, or if some of you have not downloaded it, it's pretty simple. I have the link. I'll put it in the chat. If any of you do not have Python, you're going to need it if you want to follow along. Right there, 3.8.3. Download whatever file or whatever for what platform you have. So yeah, make sure you do that. So I'm going to install it over here real quick if this ever wants to load. So this is just like a VM, I guess, but I'm just going to show you. It's very simple. You just go here, go to the website, and then you go to whatever version you have. So I have pretty sure I have a 64-bit, not really sure, we'll see. Open up this installer, install now. And I'm pretty sure it's the same thing for Mac OS. So you do the Mac OS installer here. if you're on Linux, you just use the command line. I'm pretty sure it'd just be apt-get Python 3, and boom, it's just like that. So I'm gonna let this install. I'm not gonna be using this just because I already have Python installed, but yeah, make sure you do get Python. Do you need a specific version? I'm using 3.8.3. If you're above 2.7, you should be fine, because 2.7 and beyond, that's where like the syntax changes were. So make sure you are above 2.7 and like in the threes, I assume. I'm just using 3.8.3 because that's what I've had for as long as it's been released. I have it on all my computers. So if any of you are 2.7, please upgrade. And yeah, that's pretty much it. So to verify it, we're gonna, so yeah, it's successful. I'm gonna go over here. Just to verify it, I'm gonna open up command prompt for Linux or for anybody else. It's terminal. I'm gonna do Python version. And you should see that if it says like Python is, or if it says like something like is not recognized or an internal command, either you have to try, like I say over here, try Python version or Python 3 version. Another one would be like PY3 version. Sometimes it installs in like really weird, don't really know why, but it is what it is, I guess. But you should have Python. If it doesn't work and you tried all that, you might have to change your something with your environment variables. So yeah, now I have Python installed. I'm just going to close out of this. I don't need it. We're going to install BS4, which is the kind of the main library we're going to be using. So to install that, I probably should have not closed out of that, but to install it, all it is in your terminal or your command prompt, pip install BS4. So I already have it installed, so it should like just let me do it. Yeah, it's already satisfied. So you should just have do pip install BS4. If you get any errors, share them in the chat. We'll try to figure this out. But it should be fine for the most part. It's yeah. So another thing is you want to make sure you get some sort of code editor. I wouldn't recommend Notepad, like traditional, Windows 10 or whatever Notepad, because it's not really like friendly for any programmer. You want to get something like Visual Studio, Notepad++, or Atom. I assume most of you have some sort of code editor, I hope. So that'll just be that. Okay. So I can share these links too. So put them in the chat in case any of you do not have a code editor of your choice. So just pick one of those, whatever looks cool, I guess. So anyone have any problems downloading Python or installing BS4? You can unmute or just say it in the chat. If you do, just like let me know. We'll figure it out. So what are the applications of doing like said web scraping? So let me actually just like qualitatively show you how like web scraping works. Yeah, I'm like every Wayne State professor now using Paint. I'm just kidding. So what a web scraper is essentially is we have our like script over here. Say like our Python script. And what our Python script is doing is it's going to connect to a server. So some website, let's just say like some website with an HTTP protocol. Okay, and then what we do is that gives us back a response, but the server gives us a response, and whatever response we get is usually encoded in the HTML markup language. So what we're going to do is we're going to take this data, well, it's going to go to our Python script, and we're going to parse, and we're going to do whatever we want with that data to parse that data and hopefully aggregate something. And sooner or later, we're going to see later as we get into the other projects that where we can index data and be able to like store things offline and kind of make your own search engine, if you want to call it. But it's all about like aggregating the data. There's a lot of data involved here. And once we automate getting the data, like from here, from our Python script to the web server and then getting it back. That kind of circle is like the fundamental basis of web scraping, if that makes sense. So that's pretty much what web scraping is. We're going to write that script, but I'm going to show you some applications, what you can do with some web scrapers. So I built these like a bit ago. So let's see. So I have like this web scraper here with these two Python files. So I'm going to do the first one, profile search. So these two Python files do is it uses the Wayne State. I can actually find it right here. Actually, let me see profile. Yes, right here. This website right here. What this does is I'm gonna like type in my name here. And so we're gonna be able to parse this really easily. So you can see right here, you have like a query parameter, which is pretty much like, it lets you like change what you get to see. I'm just gonna oversimplify. You get to change what you see on the, like without using the inputs. So like I'm gonna change this to like just Shah. And you can see that it'll change like throughout. It'll show me all the Shahs in the school. So that's what we're gonna utilize here with that query parameter. And so this is what I did with, this is how I like web scraped with this little project. I'm gonna show you. So Python 3 WSU profile search. Please enter a name for the search. So I'm going to put in my name and boom, it gives me my access ID. So then with this other scraper that I have, maybe profiles. Yeah, please enter an access ID. I'm going to paste that in there and boom, without opening a single website. This is a remote server. This is just a headless server. So all it did was make the request to the server or to the website, like this website, the Wayne State website, give me back the data. Okay, this is me, that's my email. I'm in the College of Engineering and my major is computer science. That is like automation. Like you just automated, not having to like go to the website and get someone's data. So pretty much like you just automated that, and it's pretty cool how you can kind of do this kind of stuff without having to open up a browser, take the data. Here we can just have this Python script. I also have like a command line thing. So if I were to just do HH3509, it automatically, like without needing an input, so you can just kind of enumerate multiple lists and get people's data just like that, if that's what you want to do, if that's what you're trying to do. So for versatile, this stuff's like pretty versatile if you know do it, if you know what you're doing. So let's learn how to do this. I'm gonna show you the code here, just to show you, just to walk you through. Then we're gonna write our first project using a website. So this is another website. So let me see, profiles.py. So pretty much what this is like how our code is probably gonna look like. If it's confusing, don't worry. It's not gonna. I'll try to just explain it. We're not gonna make this, but I was just gonna show you like a basic rundown of how this code works. So this just takes in the access ID. If you could see my cursor, that takes the access ID. So what we do is we make the request, make a GET request to the to this website right here, wayne.edu/people, and then /my access ID. Because if you go to, let me actually type this in. So Wayne/people/ access ID. You can see it's Zavaar Shah, contact information. That's all my stuff right there. So you see, that's what we're kind of doing here. We're making a GET request to this website here, and then we're gonna pretty much what this code right here, the response gives us. The response gives us this entire HTML. So everything that the server sends back to us, the Wayne.edu server, web server, whatever, sends back to you. So then what we're gonna do is we're gonna parse all this data, and that's what this kind of does. This library called Beautiful Soup BS4, very good library, because you can see this looks really complicated. You don't even know what's going on over here. Boom, you're gonna have to look into some of the values, see what it's doing. Okay, so I want the H1 tag. So you can see that my name is probably right here. So yeah, let me see. Yeah, page title. So the class, the H1 tag, so it's a heading tag. A class, the page title tag. So that attribute page title for class is unique to this value right here. So what we do is we take this value, take its text value, and that gives me my name, and vice versa for like, or it lets you do it for all this other values that I found out later on. And yeah, so a lot of it is you have to look at how the website is renders the content, because when you do that, or when you like kind of look at how the website is structured, that allows you to find the values that you want to parse and kind of scrape out, if that's what you want to call it. Yeah, we got to scrape it out. So yeah, so that's pretty much that. I'll show you the other one too, just to show you what we're gonna get into. Yeah, so this one's a little more simple. All this does is it takes this one was this one, I believe. Yeah. So this file takes like all these attributes, or I mean, all these, what are these? Let's see. All these rows, I believe. Yeah, so it takes all these rows. Yeah, all these rows. So each row, and it kind of spits it out into this nice little kind of print function over here, and lets you kind of enumerate in that sense. It's pretty versatile stuff. So we're gonna do. Let me see here. We're gonna do our first. Actually, before I do that, I want to show you one more thing here. So the first project, kind of, let's look at this website called How Many People Are in Space Right Now. So, okay, so let's say we want to scrape. Let's say we want to take data from this website. So how do we go about doing that? I mean, let's look at, first have to inspect element in Chrome and look at all the data here. Okay, so we know that each person has their own item CF, and make sure, yeah, there's 10 people in space. So you could see that we can get the number of people in space by checking how many people, or how many times item CF is mentioned throughout the yeah, you could see is mentioned throughout the HTML document. So you can either do that, and you could definitely parse all this data, but web scraping in this sense from just the HTML data is not always ideal. So another way of what you always should do is see if there's a better way. And let's look at how they get this data. So how many people in space right now.com get the data? So I'm going to refresh it, look in the network tab, and you could see, okay, there's a JSON file here, and it's an XHR request. So that means we know that there's a REST API, and a REST API was involved, which is how they probably got their data. I'm going to click on this file, and look at that. What a surprise. This is where the data comes from. So theoretically, like if we were to parse this site, like, yeah, you could scrape it through the HTML data and probably use the metadata too, but there's a JSON API. So if I were to open this in a new tab, this JSON API would be like 10 times easier to parse than like doing this HTML jargon, because all it is just JSON, and JSON is very easy to, I guess, like parse. It's 10 times easier than HTML. So it's not always ideal to be web scraping like just from the HTML. It's always good to see how the website works, maybe see where they get that data from. Because in this case, I was going to use this as an example, but obviously they had some sort of API in place already. So there's no point in doing that. But just for the sake of it, you could, as an exercise, do that if you want, just see how many times item CF is in there. But let's do our first project. So I'm going to close out of this stuff here. So the first project is through this website called Forebears.io. If you guys aren't familiar with it, it's pretty much a site that tells you a lot about your first and last name. So I'm going to type in my last name here. And yeah, that's my surname. So that's my last name. So you can see it's the 111th most common surname in the world. So approximately that many people have this surname, and it's most prevalent in Pakistan and highest density in Pakistan. No surprise there, because I am Pakistani. So it's pretty interesting. So what we're going to do here is we're going to scrape this website and give us the data from this website. So we want this value, I want this value, I want this value, and I want this value. And it's very easy to enumerate this because you can see that if I were to change, it's like, you can see /surname /Shah. So you can easily change these values. If I wanted to see the Shah forename, so I'm just going to change that to /forenames. You can see that, oh, wow, okay, no surprise there. The whole page changed to this new site talking about the forename. So, and then you could also change the last name too and see my forename and see how prevalent that is. So we're going to use this as the basis of our scraping. So let's get started with that. First, let me set up the, close out of this. So I'm going to create a folder here. This is where we're going to write the code. I'll just call it web scrape. Okay, so here, here what you can do is I'm going to open this in VS Code. That's the code editor I use. If you're using Notepad++ or whatever, you can just right click. We're going to create a couple files here. So we're going to create our first file. I'm going to click new and then text document. I'm going to call it, let's call it scraper _1.py because we're going to build like a couple of them depending on how much time we have. So by the way, if you have questions, please interrupt me or DM me on the Zoom app. I'll be happy to answer them. But what we're going to do is we're going to build the first crawler. We're going to be scraping from this website. So I'm just going to put this off to the side and this onto the side too. So here's our file here. So in case you open up your Python file, and I have this code editor, so don't get confused here. So let's do the basics. Let's import the dependencies we're going to be using. So to do that, import requests. Requests is a library that comes with Python, so you don't have to install it. I'm pretty sure. And we have to import BS4. So from BS4, import beautiful soup, just like that. And this is the actual kind of the brains of the program here. So I'm going to do that. So let's first handle the prompt, or like how we're going to take data from this. This will just be like a simple console application. It'll be like, let me open this up here. Yeah, so I'll just I'll put that on the side. So let's create a function here. I'm just going to call it def prompt. What this does, it'll return. We want to ask the user for the name, so, or the type of name. So we want them to see if they want to look at their forename or their surname. So I'm going to call this variable name type is equal to input, and we're going to ask them surname or forename. Try to make this bigger. I'm just going to full screen this for now. So we're going to ask them surname, and then I'm just going to make it like single character, so we don't have to we're going to just do a little inline if statement here. So if they enter S, then it's going to be a surname. So if it's an S, then surnames, because remember, you'll see when I put this in, oops, I forgot to put the if here. So if S, else, forenames. Okay, so the reason we're doing this is, so let's say the user inputs S, it'll turn into surnames, and this variable's name type surnames, it'll be perfect because that's what's going to be thrown into the actual request once we make that get request. So we're just setting ourselves up here for success, if you want to say that. And here's the other variable. We're going to ask them for the name. Do input. What is your name? And we're going to return both of these. Just like that. Just return it in a tuple. So yeah, now let's create our main function here. And I have to call it too at the end. So here we're going to take the values from this prompt function. I'm going to do like end type. It'll be the same thing. Name is equal to prompt. So what this, I'm just reassigning the two values returned here because this is technically a tuple. And I'm just assigning it to these two variables here. And this will be what's going to be thrown into the response. So let's set up the actual response or the request, the get request. So in order to use a request or to make it like here, I'll show you right here. I can't see it, but I'll show you. So what we need in a request is we obviously need the target URL, the URL we're going to get. So for this case, what we want is forebears.io. Obviously, that's the root. We need the root. And then we also want slash whatever they did, surnames or forenames, slash their whatever their name is. So that'll be pretty easy to kind of do. We'll just have a variable here, URL, and then I'm just going to do an F string, https://forebears.io slash, and then we'll put in the end type here. And then we'll also put the name here. And then now let's make the actual get request to the server response. So this is the response that I was talking about. It's gonna be equal to request.get. The first parameter is URL. And we also want to put in headers just so the server that we ask, like the Forebears server knows like who we are kind of. So we're going to put in a header of user agent Mozilla /5.0. It doesn't really matter what you put in here, just put in something. A lot of servers will or a lot of like web servers, if you were to make a request without a user agent header, they'll just outright deny the request because they want to serve someone who's like a real person. So in some senses it's just saying, hey, I'm a real person, let me take your data, let me steal your data, if you want to call it that. So there's also an ethical side to this. Don't go around scraping random websites. I'm just doing this for educational purposes. I know some websites, they outright forbid you taking their data, so be responsible. But yeah, let's continue with this. So now what we have is I'm going to print out response. So what we want is the text from the response. And I'll show you what that is. Let me just do this. So I'm going to do Python. I think I have it on this. Okay, yeah, so this is I'm going to do Python. I'm going to open up my terminal. If you guys don't know how to do that, open up your terminal, whatever, command prompt, cd into the directory you are in. So this is my directory. I'm going to copy that, cd, paste that here. Boom, I'm in the directory, and you can see my file is here. So I just have this open already. If you have problems with that, just let me know. So I'm going to execute this function, or execute this Python file here. So Python scraper1.py. Okay, surname or forename. This is gonna kill my OCD here. Okay, there we go. Now it looks better. Okay, so surname or forename. Let's do my surname. What is your name? Shah. Caps doesn't really matter, but you can see. Okay, now we have pretty much the entire HTML. It is a lot. Like, you can see how small it is. It is so much, and pretty much it has all the data we want. So it's the same thing. What response.txt is, it's the same thing as this. Like, if I were to edit this, copy all this, and paste it over here, it's the same thing as what we just saw in my console. It's lagging a lot because my computer is trying to format it. Okay, so yeah, with that in mind, let's continue with this. So what we want to do to use BS4 or Beautiful Soup to actually parse the HTML is I'm going to make a variable here called parsed HTML is equal to Beautiful Soup. And then the first parameter is the actual text, response.text. So what I was just printing out earlier. And then HTML.parser, because we're going to be using the HTML parser. And then so now let's see what data we want to take out from this. So we want to take the ranking, obviously. So let's see how we can take that. Oh, that's really easy. Okay, so definitely not like I planned this before, but yeah, this website is easy to scrape because all you can see is there's a class and a statistic number. And if I were to control C and then like see all there's see control F the entire document, there's only one place this exists. It is the statistic number. It exists here, and inside the value of, or inside the div of class statistic number contains the number that the data that we actually want. So that's pretty nice. So that'll be really easy. So let's see how we can actually take that data. So it's really easy. So let's call this variable ranking. So it'll point to that value right here. So let's do ranking is equal to parsed HTML dot find. So dot find, it'll let me find any div. So like I said, this is a div right here. This is a div, and I want to find with class and the value of statistic number. So it'll just be a dictionary. It'll be class with value of yeah, I have it copied. So statistic number. So just like that, this value, if I were to print it out now, ranking dot text, ranking. I'll just show you what it shows, or what it would do right now. So I'm gonna do Python scraper one. I'm gonna do my surname Shah. You could see, okay, so what find does is it returns the element which we want, and so now we want the actual number inside of here. So what we want to do is ranking.text. That's all it would do. It just give me that number. It'll be 111. So if I run this again, yeah, 111th, it'll just give me the text within that div. So that's pretty nice. So I'm gonna have a thing here. So if ranking exists, then we're gonna print, do an F print here. Name. So that'll be like my name. So Shah is the ranking.text. So it'll be the 111th most common. And then I'm going to do surname or forename. That's what this variable is, if you remember. And if you remember, it has surnames and forenames. Just for like grammar's sake, I'm just going to get rid of the last character. So it'll just be like forename. That's what that does right there. And I'll say in the world. So now just a little bit. Yeah, so now we want to do is, let's see what other, let's actually print this out now. It should be no surprise there as Shah. Okay, Shah is the 111th most common surname in the world. That's what I wanted. So now let's take the data from, where is it? Right here. So let's see, I want the, what's it called? The, I want to see where it's most prevalent in and where it's the highest density in. So to do that, you can just see right here, class detail. Okay, so let's see how many details there are. So how many classes equal to detail. I'm going to control F the document. Okay, I guess there's none. It's definitely wrong. Okay, so there's a couple details. So the only two class names in this document that's contain detail, and that's it, are the two values that I want. And then that other one is just, it won't even get picked up because I'm just looking for the class name. So class name detail will give me both countries, or the countries it's most prevalent in and the countries that the highest density is in. So it'll return. So if I were to do like find, so let me actually write this out. So I'm going to do country is equal to parsed HTML.find. I'm going to find, what was I finding? That's the div, yeah. Okay, a div with class and value of detail. This would give you just the first. So this, if I were to print country out, all it would do, it would give me the first, it'll give me the most prevalent, and because what find does is it returns only one element. So I want to find everywhere where there's a div and class name has the value of detail. So to do that, it's pretty nice. It's just a find all function. And what this does is this returns an array of tags, of HTML tags. So if I were to print country out, do that real quick. You can see that, okay, so there's two here that have, or two divs that have the detail that I wanted. And it also has the data of Pakistan. So that's exactly what I want. So we're just going to have to assume that the first value, I mean, it'll always be true because that's how it works. But the first value is going to be the most prevalent in. The second one will be the highest density because it's like top down. So we're just going to have to assume that, or just kind of take that into account. So I'm going to do if the, what's it called? If the length of country, so this doesn't even make sense. I'll just say country list. So that's what it is. So if the length of country list is equal to 2, which it should always be, then let's print out its most prevalent. Spell that right. Prevalent in, okay, some country, and then the other value will be highest density in wherever. So let's see. So now what we're going to do is we're going to take the values. So like I said over here, this is a list of div tags. It's kind of weird how it works because it's not really a div. It's just printed out to look like one, but it also has attributes too. So what you can do here is you can have country list, country list of 0. So that'll be this first value here, right here. So country list of 0 dot tx or text will just give me whatever is inside of that div. And then for the next one, country list of 1, so it's the second element or value in the array. It'll just give me Pakistan. So let's try that out. And then if there is no ranking else, we're just going to print out no results found. Okay, so let's try that out. So I'm gonna run this now. So surname or forename, I'm gonna do my surname, Shah, and you can see that it's most prevalent in. It's most prevalent in Pakistan. It's the 111th most common surname in the world, and there it is. I get the grammar or spelling, and you can see highest density. And this will work with my forename, Zavaar. It's that most common in the world. Wow. Okay, so let's try another name. So I'm going to do like a forename. Let's do something really basic here. No offense. You can see that it's the 736 most common forename. It's most prevalent in the United States and highest density in Denmark. So if I were to do like, that is, if I do that as a forename, yeah, I did it as a forename. So I'm going to just do a forenames and then Jacob. You can see that it's the same thing. It's the exact same thing. So you could see it's 736 most common forename in the world. It's most prevalent in the United States, like right there, and it's the highest density in Denmark. So pretty much we were just able to, we don't even have to access, like I don't have to open up Chrome and type in, use their, I don't have to like click search and type in my name. I don't have to use their UI. I just skipped, I skipped right to the point and typed in the values that I want. And right there, you could see through the command line, I was able to execute my code and kind of take the data from their website without having to open up Chrome or anything. And you could obviously automate this and store data, and maybe just have, maybe you could put this into like some sort of API of your own where you're just kind of stealing their data, but that's a bit counterproductive, I would say. But it's pretty nice what you can do with this. So if any of you have any problems, please let me know. Like if you don't get anything, just like ask me. if there's any part in here that you just don't get, ask me, because I did kind of fly through it. But if there are no questions, we can. If you have any problems too, like that is not related to the code, you're just having a problem like setting up the code or the what's it called, like Python or BS4 installation. Let me know. We could fix that, and maybe you could get back on track here. But yeah, that's the first project. I don't know what this is.
This is a random question. So when you were on that first page with the astronauts, how did you find that file with all the names?
Yeah, let me go back to it.
Yeah.
So with Chrome, they have the inspect element. There's a ton of tabs up here. So if you were to go to like application, you could find out all the cookies here. You should never open, you never show anyone your cookies because it sometimes has like authentication. But there's a tab here specifically called network. And what network does is I'm going to show everything. It shows you all the assets that are like not from the site. So like the flag of Russia, this is just that asset was loaded in. The flag of Germany was loaded in. All of this stuff was loaded in. And what this does is if I filter it by fetch or XHR, which is just like web requests, I could find that, okay, here's a picture of the Earth. Oh, but here's something else. There's a JSON file. So, and in this JSON file, we have crucial data here that lets you see kind of how this website parses the data and like shows you like where their backend comes from. So you're kind of able to like reverse engineer their website and see like, okay, I found out that their backend or that their front end, like this site is asks the backend, which I'm assuming is this site. So you don't ever have to actually just parse data from here. You could just go right to the chase or cut right to the chase and take data from their REST API here. And this is JSON is like 10 times easier parsing than doing an HTML. So just the network tab in Chrome and filter it by XHR, and you can see all the web requests that go through. And here's the one that I found, people in space.json. And the preview, like you can see the response is the data that I actually want. And it's like number, people, and all of that. And usually that's just how you would like find it. If you're curious, like that's how some sites like work. They just ask, you can sometimes see the back end requests, and they're very easy to just kind of steal. Like usually some websites, they're not that simple. Like they're a little more intricate, and you can't just take their backend just like that. Sometimes you need authentication, but this site is not like anything too sophisticated, so you're just able to see their data. So that answers your question.
Yeah, that's dope. Thank you.
Yeah. Anyone else have anything? I'm going too fast. Please let me know. I'm just get a water real quick. Okay. So hopefully you could, excuse me, you can probably see, oh yeah, I didn't even get to show you. If it doesn't work, so let me like try like a forename, like something random. No results found. So assuming there is no ranking. So if it's like not found, I think by default, if we're not able to find the div with this with these parameters, it'll just return null by default. So that's why I had this in here initially. And then you could see no results found. So that's pretty much how this works. Hopefully it's easy to follow and you can kind of get an idea how this works, because the next one, we're going to be kind of taking this this website. Let me get it real quick. 1 second, gotta find it. Yeah. Okay. So the next project we're gonna do is we're gonna be scraping from here. So in like specifically, we're gonna be scraping data from this URL, quote of the day. So what we're gonna do is we're going to be taking the data. So we're going to take the quote of the day. We're going to take the love quote of the day and putting them in a text file so that you never have to visit this horrendous website. I'm just kidding. You never have to visit this website. You just have it locally stored on your computer. And so let's do that. So let me see. So I'm gonna save this. I'm gonna make a new file here in my folder. I'll do it here just so you guys can see. So I'm gonna call this scraper2.py. This is gonna be our second scraper. And here's the link. I'm just gonna put that here just so I can reference it later. So same things, we're gonna import requests, because that's how we're gonna be taking data from the website, from whatever website, and then import BS, or from BS4, we're gonna import beautiful soup. And then, hold on, let me check if there's any other dependencies. We're also gonna be using regular expressions here. If you're not familiar with regular expressions, they're pretty much, or they're also known as a regex, but they pretty much like let you filter data through a kind of like its own syntax. So like I'll show you what I mean once I get to that, but it pretty much lets you like pick out specific format or specific like formatted data in like whatever way you want. I'm not very bad at explaining this, but you'll see with the formulas I've made for this program. So first thing we're gonna do is let's create a main function here. Just a good practice. Call it at the end. So let's have the main function. We're gonna want the root URL, and it'll just be this. And so I'll show you why we're going to use the root instead of just taking it directly from here. It's just going to make our lives easier. So I'm going to do response. So just like the other one, we're going to do response. Oh my God, I want you. The response is equal to requests.get, and we're going to do the root URL plus / quote of the day. So all it does is we're going to take this root URL, go to the / quote of the day. And so it'll just be the same thing as going here. And I'll show you why we're going to use the root, is because we're going to get into a little bit of web crawling and how we can take data recursively and like open up other pages from the root URL using this relative path. So this is the relative path if we're just like speaking technically here. So we also want to have our headers. I'm just gonna let's copy it from the last one we just did. So headers, and let's parse the HTML. Parse HTML is equal to beautiful soup response.text and HTML.parser. So we're just gonna be parsing it so Python can easily read it. And so now let's see how we're gonna get the quotes, like the actual quotes. So let's see. I'm gonna right click and inspect the element from this site. And so let's see where the quotes are actually stored. So it's inside this div here. Let's look at another one. So they're all like formatted the same way. So as you could see, I'm gonna look into another one, the next one. So you could see there's a pattern here. So the pattern is that there is a style that is specific to like it's specific to this these attributes here. And so let's copy this and let's see if let me copy this. Let's see, there should be a total of 6. So if I'm control Fing the attribute like throughout the entire document, and so you could see that first one's here, second one's there, or you can see that it'll just go on. And that's kind of what we want. We want to take the actual data from there. So that's how we get I guess that's how we're going to get the text. Now, how do we get the name, or like who said it? Because that's the previous thing didn't show us that. So let's see how we're going to get the name. So for the authors, all of these titles have a view author attribute. So I'm going to control F view author. There should be 6 here, yeah, because there's 6 quotes. So that's pretty nice. So now we know how to get the author names. We're just going to be find all A tags of this, and yeah, let's get into that. So now we know what to do in some sense. So I'm going to do quotes. So this is plural as in quotes. We're going to get the quotes list. So to do that, we're going to do the same thing as we did here. We're going to find all. So I'm going to do parsed. I meant to make this plural. Parsed HTML. Oops. Parsed HTML dot find all. We're going to find all div tags with the style. What was it again? Let's see. So all divs that have the actual quote have this attribute. Style is equal to whatever this is. So I'm going to find all that. And just like that, this should return all the quotes in a list. So yeah, let's get all the authors. So I'm going to do quote authors is equal to, let me see, quote authors parsed HTML dot find all. And so it was A, and each author kind of attribute, or each author element had a title attribute equal to view author. So just going to copy that. As you can see, there's 6 of them. So I already mentioned that. So yeah, let me put that here. So it was title is equal, is it title, right? I'm losing my mind here. Okay, title is equal to view author. And so what this does is this returns the list of authors for each quote. And these 2 arrays have the same length. So what we can do is we can iterate through them. So I'm going to do for I in range of the length of quotes. So what we're going to do is we're going to get each quote and we're going to throw them in a text file. So I'm going to just create a string here, an empty string here called file contents. Because what I'm trying to do here is I'm just going to try to throw what we can get into a text file and not have to like access the website and just have it in a text file. So let's do that. So file content. So now I'm going to iterate. So to get the current quote, it'd be this quote is equal to quotes of I. So what this right here, this quote would return the actual div. We don't want the div. We want the elements with, or the text within the div. So I'm gonna do dot text, and I also want this author. So this quote author is equal to quote authors of I dot text, because that's the same thing. So remember, quotes of I'll actually print it out just so you guys can see what I mean. Print out this quote and also print out this quote text, just so you guys know what I mean, what the difference is. So oops, we want to do the second one now. So 2, yeah, so you can see there's a lot. Let's see. I don't know why there's so many, but right here you can see that, where is it? Yeah, you can see, so some of the, like this quote will be what's it called? This quote will be like, some of these are just going to be like the actual div. We don't want the div. We want the text within. So you can see right here, this is the div. I don't really like how they print it on separate lines. Maybe that's just text wrapping. No, it's not. But you can see that each iteration will print out the div, then the actual text. We don't want the div, we just want the text. So that's why, that's what I was trying to do here. That makes sense. So I also want to throw this in the file that we're going to write. So file contents. I'm just going to append it into this string here. And we're just going to make it this quote. Oops, this quote. And then it'll be by this quote author. And so since they're the same, like each iteration, it's like kind of linear, like the way they have their thing. So the first iteration will be like this quote right here. And then the first iterate, yeah, so it'll be this quote right here. And within the first iteration also, it'll have like the author name. So you can see right there that they're the same thing, and we can just call them within the same iteration and it'll be the same person. So we don't like mismatch anyone. So I also want to like space this out just because like just in the file so you can see it. So then right here I'm going to do with open we'll call it quote of the day dot txt. I'm going to give it a write. So what this is doing, I'm just going to quickly, I'm just writing in the contents of the file. So file dot write and then the file contents. So just like that. What this will do is, like what this does right here is it just takes this file right here, which I don't have made, but it'll make it for me if it's not there. Give it the right permission. I believe that's what it is. Let me see. But yeah, it'll let me write into the file. And then here I'm actually writing in the contents, like the string. And let's run this now. So let's see. Let me run this. So Python scraper 2.py. Okay. Don't know why it's printing anything, but did I print anything? I don't know why it's printing stuff. But yeah, let's see if it actually made it. So right here, okay, wait, that's weird. What did I do? File contents. What? Co-authors of I think I screwed something up here. Let me see. That's bizarre. Why did it? Where'd the file go? Yeah, it's not supposed to be. Oh, I forgot this. I don't know why it was printing stuff. It's not supposed to print anything. But let's see. So let me run this again. I'll delete this. I forgot to put the .txt or text back, so it was just giving the whole tag. And then you can see right here, boom, that's what we want. In this text file, we were able to take the data from this website and, so we took the data from this website, threw it in a text file, and you could probably put this into a cron task and just let it run like every day at like 12 o'clock or like 11:59, whatever, and get a new quotes of the day every day without having to ever touch their website. And the possibilities are endless. Maybe you could put this into another backend API of your own that you want to make and just steal their data, whatever. It's imagination, you could do a lot with it. So that's what you can do with the first part of this. So anyone have any questions, like just regarding the content of what we just covered? Because next thing we're going to do is we're going to kind of get into a little bit of web crawling, and we're going to be saving files from the web server by opening different files or different links within the website and going to different sites, which is what that whole root URL thing is. So does anyone have any questions?
Is there a reason my file wouldn't be opening? Because when I do try to open it, it's like empty.
Your like the TXT file?
Yeah.
Mine was
What's up? Okay, so let's see.
mine was empty too.
You have it just like this, like having it
Yeah.
Okay, let me think. So maybe make
I'm on a
the
Mac.
yeah,
on a
maybe
Mac.
make the file first.
Okay.
Like make the qotd.txt first and then run it. Maybe that's why. I could try like, let me see. Oops, I don't even have that installed here. God, okay. Did that work?
Maybe I need to install it. I'm not sure.
200 megabytes. Okay, never mind. I'm not gonna do that. What do you have to install?
I don't know. Yeah, it's not working, but I'm on a Mac. Maybe that's why. I'm not sure. But did the other person get it fixed?
Are you also on a Mac?
No, I'm not.
Okay.
I'm just looking through your code real quick, see if there's like any typos I made.
You want me to copy and paste this in the chat and see if it like?
Oh, I think I know what's up. At a hyphen and viewer.
This
Yeah, it's
that's working. Okay, let me
Yeah.
see. Bit different on a Mac.
I don't know, but should be fine, right?
But, I mean, if you want, you could just print out file contents at the end.
Okay.
If it doesn't work, you could try making the like this instead of a W to an A. I think that's what they were just saying on this forum.
Okay. Let's try this.
Yeah, if that doesn't work, you just print it out and see it there. It's not that big of a deal. Let me see. Should do the same thing. Yeah.
Cool.
I fix it or not?
No, but I'll just talk to you later.
All right. Yeah, that's fine. That's fine. Okay, so
It's fine. Yeah, let me see if it prints. Yeah, it's fine. We'll talk to you
Okay.
later.
So now let's like what I want to do now is let's see. So I'm gonna go back to the quote of the day here, and I want so if I open up this like each of these divs or whatever these elements are, every time I hover over them, I can click on them. So if I click on it, it goes to this website, this specific website here that has a picture and other like data that you could possibly scrape. So what I'm gonna do for this example, or for like part 2 of this kind of scraper 2, is I'm gonna take this image and download it to my computer. So, and this is essentially what web crawling is that you have a root kind of you kind of have like a head, like one URL that you start at, and every link that it finds, the spider will crawl on all of these links on the web, which is like analogous to the web and like web crawling. It'll open all these, and usually they're recursive. Like if you had like a real like web crawler, they would go on, keep clicking, it'll keep clicking, and it's just a lot of data. But for this introduction, all I'm gonna do is it's gonna open this new website, take this image right here and download it to my computer, and shouldn't be too hard. So let's try to do that now. So for now, what I'm gonna do is I'll just comment this stuff out. I'm just gonna comment this stuff out because now I'm just gonna open up these links. So how are we gonna get these links? So there's ways you can do this. Let's see. So you can see right here href that has this class too, but each of these classes, like you'll start to realize like you can't crawl every website. Like if I were to go to like Google, oh man, I just Googled. Okay, so if I were to like just type in something random and then like try to crawl Google, you could see that this is like all this stuff is just random. Like it's hard to parse because they're all like, was that 6 characters? It's hard, and you have to do a lot of mental gymnastics there to figure that out. And I don't even think it's possible because they also have like what's it called? Like, are you a robot? That's what that kind of goes against. So sometimes you're gonna see that it's hard to do that, especially with this. This looks kind of random, not really, but the way I have it now is we're going to be using regular expressions. So what I'm going to do is first I'll show you why I can't just take all the A tags. So I'm going to do like print, let's see, parsed HTML. It's parsed HTML dot find was it find all, and then we're going to find like all the A tags. And what else do they have? So these are all changing. If I were to like open up another one, you can see that, okay, this class name is different. Pretty sure view quote. Let me see. Okay, so there's 7 matches for view quote. So honestly, if you were to just use the attribute view code and have it so that you have the title, like it'll just be this exact same thing, but it would just be view quote. Could do that and filter out the first thing. Actually, I didn't even realize that was a thing. But what I did was instead, I wrote a regular expression that'll just filter out all of these href tags, so we never have to even use the BS4 library. So you honestly could do title, like this would do the exact same thing. Here's what I was saying. View quote, and so what I'm trying to do is just like get this URL somehow. I want this URL just so I can open it up and take this image. So in order to do that, I need to take this URL. So that's the purpose of what I'm trying to do here. So what I could do here is if I were to run this, you could see that, okay, we get all the tags here, and we could just take the href value. Yeah, that'd work. As for this instance, because not every time it's going to be that, cut and dry. So for this instance, I'm going to be using a regular expression. So we don't even have to use the BS4 library. This is just going to be taking the raw text from it. So I'm going to be opening up here. Let me take all of this and copy this. Go to this website here called regexer. So this is where you build regular expressions. So this is just another handy way of kind of parsing data, taking what you want. So this formula I wrote beforehand will just take everywhere. It'll take all the URLs. Yeah, it'll take all these URLs that have /quote. So let me like inspect element here. So it'll take all these elements. Let me like zoom this in. I don't know if you guys can even see that, but yeah, it'll take all these /quotes /whatever, and it'll give that back to me. So that's what this formula I wrote. So I'm going to show you the formula now. So // I'm not going to go into the actual formula because they're kind of tricky, but just bear with me here. I'm going to do this and then plus \w plus. So you could see, yeah, so here, what this formula does is it just takes /quotes, like the URL, it matches this entire thing, and I'll show you it matched it all over here. And if I find somewhere, yeah, so right here, it matched with this formula I wrote, it matched it here. So I'm going to make the Python code just take these values, open up a separate separate response, and download the pictures there, or like download the pictures from whatever URL is here, because this URL plus the root URL, which is brainyquote.com. So if I were to combine these two things, you can see that it'll open up that. So that's how I'm going to kind of enumerate this. Let's see. So let's get to that. So I'm going to do quote URLs. This will be plural, so it'll be a list of URLs is equal to re.findAll. So re is the regular expression library for Python. So I'm going to do re.findAll, and I'm going to have an R string here, and then put the same kind of formula I had beforehand. So \w /quotes / plus white space, which is what that is. And that should be the formula. So I put that formula in. And so remember how I just took all this HTML data from here. So I just did that. Remember, that's just response.text. So that's the response we get from the GET request. So response.text. And that's also what we throw into the BS4 library for parsing. But we don't need to parse it since we just have a formula that kind of just takes it without having to parse anything. It just matches with this formula. So that's pretty handy. So we don't even have to use BS4 here. So I'm also, if you noticed, right here, it repeats the first one for some reason. That's probably just because right here, it's like twice, I'd imagine. So I'm just going to skip the first one. So it'll be from 1 to the end. So what this does is this should print out, try to print this out, quote URLs and run it. You can see right here, boom, it's just like that. It is. I don't know why it's printing stuff. It's really weird. I don't know what this all is, but it's just there, I guess. Okay, so you can see right here, this array is what we want. These have all the quotes. So remember, if we combine this relative URL with the root URL, we will get the page that we want to go to, which was like this page. And this is where that image is like located, or at least like for the first one, it's already there, but for these ones, it's not. So we can, this URL right here will have the image that we want. So we're gonna go ahead and download this. So to do that, we have to parse through all the, or we have to iterate through the quote URL. So for quote URL in quote URLs, we're gonna make a, so it'll be this URL is equal to the root URL. So that's brainyquote.com plus the relative URL. So that'll be the quote URL of each iteration. And we're also just going to print that out. Print going to, and then like the URL that we're going to go to. So just to show that it's doing that. And then let's make a new request. So it'll be quote page. So what we're going to do is I'm setting this variable quote page equal to the response from this site, not this site, because we already have this data, but just for this site. But we're going to want it this site because this has the data that we want. So we're just making another request now, or a new request. So requests.get this URL and throw in the same headers. And so the quote page now has, our quote page dot text would have like what we want or what data we want, or like the parse, like the, what am I saying? The HTML data, it has the HTML data. So to parse the HTML data, we're going to do quote page parsed is equal to beautiful soup, because now we're just going to be using that library, and quote page dot text. So remember that was the like the response dot text, and we're going to be using HTML parser. And so what exactly are we going to parse from this site? So yeah, you could take, you could find, I'm assuming this is like the only image. Maybe there's another image here. Yeah, this image also has a thing. And like you probably could just take the image here, but there's also a little handy trick. Some websites, if you go into their head, into their like their head tag, you can find all these properties. The gold, where the gold is located, is the OG image stuff. So that's just like if, I don't know if you guys noticed this, but like when someone sends something on the Discord, it auto embeds. So what it does is when someone sends like a link on Discord, the Discord web scraper or web crawler will look through all the meta tags. It'll find the OG image and it'll put that as the attribute for their let me see if I can show you like what I'm talking about. So like just this, for example, on the Discord. So you see how this link right here Oh, my Discord just froze. Give me a sec. Yeah, so this link right here is like automatically, like Discord has like a thing here that's a Zoom video. Okay, this is the video, or like this has the attribute, and then this is like the thing. So I'll just show you what I mean. Like I'll just open this up, copy link. So I'll go over here, and then I'll show you. If I look in the head tag, I guarantee you there will be, yeah, right here, OG description. So that was where this was. OG title, that was where that other thing was, right here. And then I'm assuming there's like a link or something. Yeah, URL, OG URL. And that's like the link that'd be clickable on Discord. You probably noticed this on Twitter. Those are web scrapers too. It's just automated through Twitter. So we're going to be using that from there. So to do that, where is it showing it right here? We're just going to be taking the OG image property. So that's relatively straightforward. We just take image URL, because what this is we're getting the image URL from the content. So we're going to do image URL is equal to quote page parsed dot find. We're not going to find all because there's only one, and we're just going to find the meta tag, because remember this is a meta tag, not a div or anything, with the property of OG image. So remember, this has the attribute property, or the attribute is property, and then like the actual value is OG image. So that's what we're doing right there. And so what this would do is we're going to print out, I'll just print it out just to show you image URL, just like that. You can see right there, it shows me all of the meta tag to which contains like the image right here. So now we have like the images. So, well, we don't actually have the images. We have the tag that has the image. So to do that, it's weird. I know it doesn't look like right. This doesn't look like a dictionary, but it like technically is. Just when it's printed out, it looks like a HTML tag. But if you were to just do pretend like it's a dictionary, you do you take the index of content, or take the key of content, and the key of content would be equal to this image, or the URL right there. So let me run this again, and just like that. Oh, I didn't save it. Try that again. Boom, just like that, you have these URLs now. Just pretend like this value right here is a dictionary in which it has properties of content. It has a property of OG image. And what else does it have? I think that's it. Yeah, it only has those two things. So we're using that as just a dictionary. That's it. So what I'm going to do now is I'm going to create a function called save image from URL. And then this will just have one parameter of URL. And we're going to have file extension. So what this function is going to do is it's just going to save the image from the URL like locally to our computer. So I'm going to just create a variable called file extension. So this will be like the file, like the file name, I guess. So it'll be is equal to URL dot split slash. So if we split out like a URL, like let me show you what I'm talking about here. Oops, that's not where I want to go. No, I just press the same one again. Okay, so if I were to go like right here and open up this image. Okay, so you can see that each image has like a slash, and each slash is like a directory, I guess, into another directory. And so what we want is we want the last slash, because that gives you the file name. So what I'm going to do is I'm going to split this up. So I'll show you what I mean. Just do it in like Node real quick. So I'm just going to take this here dot split slash, and you can see right here the last element is the file name that we're going to we're going to use to write the data to. So that's what I'm going to do here with this. So URL that's split. So to take the last one, it's just -1. So that's what that does. And this isn't really a file extension because we just saw that it's just a file name. So file name. And then we're going to have to we have to do a get request to this. So let's actually see what a get request to that would look like to a file instead of like an HTML. Yeah, so it wouldn't even let you because it's a binary output. It's a file. So when if you were to do a request, it would be like a buffer. So we're gonna convert that buffer or the binary to like the digital file like once we save it in here. So I'll do that real quick. So now just do the request itself. Response is equal to requests.get the URL. So this response will not have a .text, or if it will not be like parcel. It won't make any sense because this is just a file buffer. So to like save this, we're gonna open a file called we're gonna open with file name, and we're gonna write it as binary. So WB as F, and then F.write response.content. So response.content is like the binary of like the request. So if I were to do like response, like this value right here would just be the it wouldn't be any HTML, it would just be the actual JPEG buffer because this isn't not an HTML, this is a JPEG file. So that's how we're going to do that real quick. So with that in mind, we now have this function done. So I'm going to do save image from URL.
Hey, Zavaar, can you go back up for a sec?
Yeah,
Sorry. No, you're good.
I can share this code after when we're done
Okay,
too.
I'm good. I'm all
Yeah.
good.
Yeah. If anyone else is like behind too, just let me know. I'm just kind of speeding through this. So what this does is, yeah, so now we can actually save the file to our directory. So it'll just be in the relative directory. So it'll be in the same directory. So once I run this, should just be a ton of pictures of like all of this stuff. So it'll be like this. It'll be that. It'll be all the quote of the days, but just in a JPEG format taken from directly from the website. So I'm gonna run this now. So it's going, you could see it's going to all these sites and it's taking the data. I'm gonna look over here. You could see that we have like all of our pictures here. So there's 6 of them. Yeah, there's 6 quote of the day. So this is the first one. This is the second one. And you could see like we didn't have to touch the website. It just downloaded them automatically. I didn't even have to open the website. This is completely headless. So no need to open up like go here and then right click, save image as, none of that nonsense. We just did it, we just did it through code. So that's what that does. If anyone has any questions, please let me know. If if something didn't make sense, or just message me. Yeah, just let me know. Go back to the code. If anyone's like still copying, I'll just keep it out here for a little bit. One sec. Give me a minute. Just give me 1 sec here. Okay. Okay, so let's see. So now we're done with this. This is pretty much like, this is the introduction to web scraping. So right here, what we did This is somewhat recursive, not really, but what it does is like the next thing we're gonna do is gonna be like a crawler. I don't know if I'm able to. It's kind of a lot of code, but we're gonna try to power through it. So what this is we're getting the quotes, the quote URLs. We're getting a URL from this site. Let me actually write this out. So what we're doing is we're going to our root site. So this is like the quote of the day. Quote of the day site. So what we're doing is we have our crawler here. I'll just do it as a spider here. Really good spider. So we have our spider. The quote of the day site has a couple things here. So in its site, it has references to a couple different other sites. So I'm just kind of summarizing what we just did. So what are our Python script, it connected to this website. And then what it did was over here for quote unquote URLs, like the iteration of the other quotes, we went to the other sites. So we went to Q site 1, and then we went like quote site 1, and then it'll go to the other quote Q site, Q site 2, and you could see that this from this one page, this is just one page, references to like 6 other, I mean, it was 6 other pages that exactly, but this is what web crawling is, because our crawler here, it went over here. This is such a bad spider, I'm sorry, but it went there, it took that path, took this path, it took that path, and it also took that path. It took the metadata, and then we downloaded the file from that site. So then we went back to our Python script, and then back to like our memory or wherever this is stored. It goes to our file. And what we did is we kind of branched off. And so this is like the web, like this here is like the reference, the reference of other sites. I'm just trying to, I don't know how to say it, but it's just like one site refers to more sites. And then what a web crawler does, like how it takes like tons of data, is that this site points to another site. So for example, if I were to show you this site, yeah, like this page, this quote site here, it has other links. So this link is related topic, so it goes to this site. Oh wow, okay, so now we have an innovator quotes. Okay, let's pretend like we're a web crawler. We're going to take all these quote data, we're going to index it, save it somewhere. Okay, now there's so many other quotes, so I'm going to open up these quotes. And so like a web crawler would open up all these quotes, take the data within here, and it'll be recursive in some sense. It'll just keep on pressing all those links, and it'll save it back to like wherever the like whatever storage you have. So that I'm just gonna like draw like this is like a SQL kind of thing. I don't know what I'm trying to draw there, but this is like our storage. So we have all that data recursively being sent out or recursively being taken in. So each site opens up more, and you'll see that this like is exponential because that opens up more, and then it'll be like a node tree or like a binary tree, like an infinite one. It'll just like be like that reference is there, and then this references to like 2 other. Well, that's not how it works, but like you see that it just keeps growing, and these sites have more sites, and that's pretty much how a web crawler works. Or yeah, web crawler works. It just keeps doing that, and that's how like Google has like, if I were to just search up quotes on Google, that's how Google has like, how many is that? That's like 4 billion results. There's so much data involved here. It's crazy. So I'm gonna do the next project here, which is gonna kind of scratch the surface of web crawling. I don't know if we're gonna have enough time to finish it, but if any of you want to stick around, that'd be cool. Let's see. So I'm gonna create a file here called call it crawler.py, and what we're gonna do is we're gonna go to this website. Actually, let me make sure if it's that website. Yeah, it's this website. Okay. It's gonna be this website right here. So Wikipedia, Oh God, my computer's dying. Yeah, so Wikipedia has a ton of information. So what you could do is you could like you could open all these links like speculative fiction, all this stuff. So if you, let's say your crawler opens this site up, okay, now look at all these other links. Oh my God, there's so much data here. You could scrape, you could eat all this data up, open up another one, eat all that data up, save it to your computer or whatever, open that data up, open all these. It's just, it's completely like exponential just how much information is involved. Like if we were to actually do this with Wikipedia, we're going to kind of do this with Wikipedia. Kind of see how Google or like other search engines index data. It's like save data. So yeah, let's do this. So I'm gonna minimize that. If any of you have any questions, also just let me know. This is maybe it's too complicated. I don't know. So I'm just gonna import requests because that's what we've been using from BS4. Import beautiful soup. From time, import sleep. I'll show you what we're gonna do for that. It'll just stall it'll slow down our program because sometimes it'll just go so fast, and I also don't want to explode my computer because there is a lot of data that is involved. So I'm gonna create some global variables here. So I'm gonna have a visited because sometimes like when you're on this site, for instance, like some sites cross-reference each other and I don't want to crawl the same website. So I'm just going to keep track of that in this array right here, visited, and then iterations. So iterations is just going to be like a counter variable that I'll show you. It'll be like how many sites that we visited. It'll just keep track of that. And then we'll also have a root URL, which is equal to https://english or en.wikipedia.org. So it'll be the root URL. And so let's create our main function here, def main. Let's create a response here. So let's create a get request here. So requests.get root URL. So what we're gonna do is we want to index all the data, or yeah, we want to click on all these links over here, like on this site. There's so many, I know. So essentially we're just going to be taking this relative directory. So it'll be root URL plus that. So it'll just be the same as this, like combined, and you'll see why the root URL is important. I hope you could see why it was kind of important in the last one, but we'll see again. So we also want to throw in headers because I want to type that out again. Okay, so yeah, Mozilla 5.0. Okay, so parsed HTML, do the same thing. Beautiful soup. Response dot text, and then second parameter is HTML dot parser, and category. So yeah, so now I'm gonna have this variable called category links. So I'll show you what that is. So what I want is I want all these URLs. Now there are some URLs like over here, like edit and watch. We don't care about those. There's also some of these things like help and like contact us. I don't care about those. There's probably no like useful information there. I just want like the meat. So, excuse me, part of this process, or like part of this doing this is what I'm gonna do is, let's see right here. So yeah, so if I were to hover over each of these, no, I didn't mean to go there. If I were to hover over each of these, they have a title of like portal : something. So they all have portal. So I could do something with that. And yeah, they all have something with /wiki/portal. So I'm going to use that to my advantage. So there's this thing in BS4 that allows you to use regular expressions. So I'm going to be using that in conjunction with the BS4 library because you can do both. So I'll show you how to do that. So I want to get the category links. So it'll just be these links. I'm just calling them categories because they seem like broad enough. So it's plural too. This is going to be an array. We parsed HTML parsed HTML dot find all, and then we want a tags, of course, with the href. Oops, no, it has to be href because that's like the link. So we want this link right here to like crawl or to like go to and then take data from. So to do that, we're gonna use this this formula that I made for regular expressions. I don't have time to show it, but I'm just gonna write it out. So re.compile. So all this does is it just makes, it says it right here, it just returns a pattern object. And this library lets you use regular expressions. So I'm gonna do re.compile my regular expression. So R string and then backslash wiki backslash or oops slash wiki slash portal colon plus white space, or that's not what that is, but yeah, plus that. And so what this does, this regular expression right here, see if I can actually use them. No, you can't use it in Chrome, but what it does is it just takes, I want to click on it, it just takes this href value and it gives us that entirely. That's all this does, and we have it under the href, so that's where that regular expression comes in. So every a tag with an href property of this link will be checked to see if it follows this regular expression formula. So that's how it will match the data. And so it like by in theory, like I can't really show it, but I would print it out, but in theory it would just have a list of all those a tags. So it'll give us a list of the a tags, but we want a list of the ha.href tags, like the href values. We want the actual URL. So to do that, I'm gonna have, we also don't want to have duplicated or duplicate values. So what I'm gonna do is I'm gonna set a thing here called filtered list or filtered links is equal to this is going to be an inline for loop. So root, or I'll just do the for part. So for URL in category or links. So this is just an inline for loop. So on the left hand, we have like the actual value that we want in the array. So it'll be root URL plus URL of href. So what this does is, you see how all of these href tags or href values are /wiki. It doesn't give us the absolute. It doesn't give us like the full URL to actually scrape. Because if we were to type this in on Google and open this up, like just like or do a request get to here, it's not like an HTTP thing. Like yeah, you could Google it, but we want the direct URL. So this is what this is doing: root URL plus the URL of href. Remember URL, like each iteration of URL, pretend like each tag is a dictionary because that's how this library works. So we take the href tag, we add it to the root URL, and we also want to get rid of any duplicates. So to do that in Python, you could just have a list, and you could have sets inside of the list so that it gets rid of all duplicates. So what this would do is, let me print this out, filtered links, and I'll run this. Do that. Okay, so you can see every single category here. You can see like all these like different categories, like clothing's right here. What is this? Ecology, football in Africa, like all these categories. Now we have like an actual link to access them. So here's where the kind of this is where we start like branching off into the crawling. So I'm gonna have a function here called crawl. So def crawl URL. And so I want to access these variables just to keep track of what's going on. So I'm just going to refer them in the from the global. So visited, and we also want to what's it called? Yeah, iterations for both of these. So now now we can keep track of these. So every time we crawl, So iterations plus equal to 1. We're just going to increment it by 1. And so let me space this out. So what we're going to do with the filtered links. So for each link that we have in that list that I showed you earlier, I'll do like for URL in filtered. Do that. Okay, filtered links for URL. We're just going to crawl the URL. So we're going to, each filtered link, all we're going to do is call this function with that URL from that array. So it'll be like, it'll just be calling this function. It'll be a lot of times it'll call this function, but you'll see the recursion in a bit once we get to that. So now let's do a response or get request requests dot get. I hate this. Auto imports. I didn't even see that. So request dot get. Then the URL. Yeah, so the URL comes from the parameter, and we also want to have headers for each request. Okay, and then we want to get the parsed data, so that'll be the beautiful soup stuff. So beautiful soup of response.text and then html.parser. And right there you can see, okay, so yeah, so right there we have the parse stuff. So now we can actually get all the A tags. So A tags, if you don't know, or if you haven't noticed, they're the ones that actually house links, like clickable links. So we're gonna find all the A tags in whatever document we open, or whatever URL we open. So I'm gonna do links is equal to parsed dot find all. We're just gonna find all A, and then we'll do the filtering later. Like we don't want all of these URLs, and yeah, we'll do that later. This has to be plural too. It should be. So each time we do something, I'm just gonna print out URL to see where we're at and how many iterations we're at. So yeah, so now we can actually iterate through the links array. So I'm gonna do for link in links. So this will be like, so each link will be like each iteration. If I were to print out a link, remember it'll just print out the A tag. Now to actually get the href value of the A tag, we pretend like it's a dictionary and access the key just like that, and that'll give us whatever value this opens up to be right there. So yeah, so that's how we get the href value. So I'm gonna do a quick little condition here. If link.get href, so if that exists, then we're gonna like continue forward. If it doesn't, then I mean an A tag should generally have an href tag, so that shouldn't really matter, but I'm just gonna have it there anyways. So this link is equal to what I just did earlier, like link of href, because if I were to just like not have this and href didn't exist, then you'd get like a dictionary error. So this is just to like not have that error. So I'm gonna have so remember each document now has like all these links. So, and remember they're all relative too. So what I need is I need to have a target link. So that I'm going to call it this next link, or this next URL is equal to root URL plus this link. So remember, since these are all relative, we have to add it to the root URL. And once I do that, here's where the filtering comes in. So excuse me for the syntax and what I did here. I did this pretty late, so it's just going to be a ton of if conditions. So the first one is if I already pre-did this to see like which ones like to see like the stuff that I don't want, and it worked pretty well. So I'm just going to kind of write this through. So if /wiki, so if this substring is inside of, or it exists within this link, then yes, please continue. And if Wikipedia colon is not in this link. Remember, some of these links, like just bear with me here. I'm gonna type a lot of stuff in because some of these links are just like I mentioned, like contact us, learn to edit. Like I don't care about these links. So this is just from my research, I guess, of what I found. Like ignores like the stuff I don't want. So not in this link. And then and what else do I have here? And templates not in this link. So if you were to do this yourself, you'd have to like look at how their website is structured, look at all the stuff you don't want. And I found this stuff by trial and error. And so you can see the one I just typed, or the one I will just type. So this, or not in this link, and special is not in this link. So like, as you can see right here, like I don't care about like talk or like their UI controls. I just care about the actual data. So that's what a lot of this stuff is going to be. So is in this link, it's not, or and where am I? User not in this link, and what else? And file. We don't care about files. They don't really have any data that I want. I just kind of care about the text data. This link. And for the big one. So this is going to have two conditions. So what I'm going to do is I don't want to visit the same website again. So I have this condition here. The next URL. This next URL. So this next URL not in visited. And bear with me on the syntax here. I'm sorry. I'm confused. What did I just do? Okay, yeah. So okay, so and this link is not, or yeah, this link not in visited. So if it's not in the visited array, and I'll show you, we're going to be appending to the visited array. So all this does is just, this doesn't let us have duplicates. Some of these links, so this link is a direct link, and this next URL is like another direct link, I guess. But we had to like add it so they're different. So I'll show you what we're going to do with that now. So here I'm going to have an if statement. So if it's a direct link, in this link, so this link, remember this is like some A tags. I don't know if I could show you an example, but some A tags have like a direct URL, and we don't want to add the root URL plus another direct URL, yes, because what you would have is just two URLs like combined with each other, and that's no good. So I'm just going to be looking at this link specifically, just like if it's relative or not. This is what this condition is going to check. So if it's and usually how we can check if it's a relative link or a direct link is if there's an HTTP like in the beginning of it. So if you look here, if this is a direct link because it has an HTTPS. So HTTP is like the substring within. And then like a relative link, for example, which I showed you guys before, it'd be like /wiki/ like hello world. So that's what a relative link is. This does not have an HTTP in front of it. And what we would do there is then we'd filter it up. So let's do that. So yeah, first I'm going to, so if it is a direct link, we're going to do visited.append this link. And we're going to print visiting spell it right, yeah, direct site. Just going to print this out, and then this link, and then iterations. I'll also print out iterations. And then this is where the recursion comes into. We're going to call a function within itself, and we're going to crawl this link that we just have, this direct link that we have. let's say like if it's a relative URL, then we're gonna have visited dot append what's it called? We're gonna append this next URL, and this is the actual. I should have made these naming conventions are really bad. I'm sorry, but this next URL is gonna be like the root plus the like this would be like root and or actually this would be like convert relative URL to direct URL. Okay, and so here we're gonna append that to there and print out visiting new site and this next URL. We're gonna print that out like the site that we're gonna visit, then iterations just to show you like how many times this has been done. So crawl, I'm gonna crawl this, or this will be this next URL, yeah. And so what this does is like this is the recursion, and then at the end, sleep for 1 second, even though it's not going to do much because these functions are just going to, once you'll see once I start executing, I know I have like a little bit of time left, just give me a second here. I also want to keep track of some data because obviously you could write all this data out, but the point I'm trying to show you is the recursive nature of web crawlers and that they keep pressing links. So I didn't really like show you the actual data indexing, but theoretically, like from what you learned, maybe if you want to continue this project, you could maybe save this, like the file from like parsed, like maybe you could find some data here, like within this, within here and save it somewhere and make your own search engine from there by like control Fing in like a big full, like big file. But for now, I'm just going to show, I'm going to keep track of what I've visited. So iteration. So if every 50 times, I'm just going to save to a file like the current iteration or the current URLs that I've been to or that I've like had a GET request to. So I'm going to do with open. I'll create a file here, visited.txt, put it in the right mode, and then encoding. You want to have encoding because from when I was testing this, some characters, like usually in Wikipedia, that are just like some really bizarre characters here that can't be encoded by default. So you have to use UTF-8 in order to encode like everything. So that just makes it like not crash, I guess. So I'm also gonna I'm gonna write this to the file. So I'm gonna write in I'll join in like what I've visited. So join visited. So what I'm doing here is I'm just kind of taking the visited array. So this array of URLs, I'm just going to join it into a string here with the separator of a new line. So also this isn't right. So yeah, so it'll be every 50 iterations, boom, it'll write it to a file, and that should be it. Hoping it didn't screw anything up. Let's see what, oh yeah, requests. Okay, so let me try this out. I screw something up. Yep, let's see. So okay. Oh, forgot the colon. Right, yeah. Yeah, forgot the colon. Okay. Yeah, so let's see. It's even working. Okay, there we go. So now you can see it's connecting, it's visiting all these sites. And what it's doing is it's first it's going to look through all of these URLs, like through the filtered links to that portal site, and then it'll go through. You can see it's already started to go through visiting new site. So those are the relative sites, right? Yeah, new site is the direct. Yeah, new site is the relative site. Direct sites are the ones that were like that came like direct with the URL, like for whatever reason they were. But you could see we're already at 100 websites, and you can see my computer really hates this. Let's see right here, the Windows terminal, Python already using, you can see my RAM is just getting dominated here, and it'll exponentially, I mean, obviously up to a limit because my computer isn't that fast, and also my internet card is limited too. But you can see it's going really slow. And if we look into that file, see if it's even saved it yet. It should have saved it. Yeah, visited.txt. You can see right here, It has all the URLs that I've quote unquote indexed. I didn't really index them yet, just because like you can do that on your own. I just want to show you how web crawlers work, how they're recursive. And so you can see if I were to leave this on, by default, Python will automatically shut down after like 500 recursion, because I believe the recursion depth for a standard Python function is 500. But it'll also just shut down soon because like this RAM it's already using half a gig of RAM, just because yeah, just because I've had that array set up like that. So and it's also saving like all the body stuff. So it's pretty inefficient, but this is how they index stuff. If anyone has any questions, like I didn't really show like this is pretty much how like web crawlers work and how Google takes their data. They have a list of a bunch of sites. They go to those sites. They open more sites from those sites, and you could see it just branches off into like a tree, and it'll just keep going on and on. And that's how Google has so many search results. And it does it so fast. It's incredible. Like 800. What is that? Like 8 million in half a second. It's crazy, and it's all indexed with their super fast servers. Here I'm indexing it around like 1 per second. Actually, not even, because this sleep function doesn't do anything, because each crawler that gets called will what's it called? Will just like it won't really matter because it's not linear, because it's exponentiating. If that makes sense. But yeah, that's pretty much it. We're already at like 460 iterations. The program will crash soon just because I'm taking up almost a gig of RAM on my computer. So I'll just close this out. You can see this file is getting massive. We're at 400 stored, and all these URLs are now stored as sites that I have visited in this kind of project, I guess. So yeah, if anyone has any questions, please let me know. That's pretty much all I have planned. Let me see. It's actually perfect timing. But yeah, that's all I had. Yeah, I hope you guys learned something. I'm sorry if I went fast. If you'd have like a problem, or you like don't get something, please let me know. It's yeah, just it's no problem. It's pretty cool stuff. And yeah, I stopped this. So yeah, that's all I have planned. Yeah.
Thanks, Zavaar. That was dope.
Yeah, no problem.
Yeah, thanks. Definitely learned
thank
a
you.
lot.
It was really awesome.
Glad it helped. Stop that.